Hi everyone, and welcome to What's New in Global Mapper Pro for version 26.1. My name is Jeff Hatzel. I'm a Senior Product Manager at Blue Marble. I'm joined today by my friend and colleague and fellow product manager, Mackenzie Mills. How you doing today, Mac?
I am doing well, Jeff. How are you?
Good, good, and thanks for joining me as always. Always nice to have some company on these webinars.
Yes, it is, and I'm excited to talk about what's new in Global Mapper Pro version 26.1.
Before we get into it, let's go through what we're going to look at today. So some of the new features in 26.1 Pro uh, cover kind of the three, I guess, sort of main components of the Pro version. Point cloud analysis, pixels to points related updates, that's our photogrammetric tool. Um, and then the Insight Learning Engine, which I'm sure you know or familiar with, came out in beta this past fall in version 26, and that has some updates to it as well. And we're going to do this kind of mix of kind of both talking and live demos in the app. Mackenzie, do you want to start us off?
We're going to start by talking about a little bit of point cloud classification. Now, Global Mapper Pro has tools for automatic point cloud classification, as well as manual classification. While we would like everything to be automatic all the time when it comes to classifying millions, if not billions of points, there is often a little bit of a need for just some fine tuning with some manual classification, depending on how exactly you want your features classified, the type of features you're classifying, and the data that you're working with. Manual classification has been in Global Mapper for quite a while. It really is an essential tool for any type of classification, an aid to that automatic method. But in version 26.1, we've replaced the toolbar for manual classification that had a set number of buttons on it with a manual classification tool set. So this is a floating pane that you can open when you need it, and has a little bit more flexibility and some added features for manual classification there. So with that little intro, I'm going to flip over to a Global Mapper workspace that I have open here. And I've just got a small tile of point cloud data open, a couple of big buildings and a parking lot. We're seeing that in 2D and the 3D view. And docked below my control center is our manual classification tool set. So this is opened from the main Lidar toolbar. Previous versions of Global Mapper had multiple Lidar toolbars. We're down to one. We've been making an effort to sort of neaten up the number of toolbars we have and make them more effective, so that it just decreases the screen real estate they take up, and you have more room to display your data and those analysis dialogues that are really the power of Global Mapper Pro. So from this Lidar toolbar, we've got a classification little fly out drop down menu here where we've got access to that manual classification tool, and then some older favorites, the switch Lidar class. We've got the automatic point cloud analysis, and of course our spectral partitioning tool. So all of those classification tools under a drop down on this one toolbar, accessible still from the top of your screen, or of course they are available in the Lidar analysis menu. Took me a minute to find that one. So before I jump into a little bit of active demo for manual classification, I just wanted to go over a new report that we're getting from automatic classification, because with this data set, it started unclassified, I classified ground, and then I subsequently classified buildings and vegetation. And from that classification of buildings and vegetation with the automatic point cloud analysis tool, I chose to produce a report. And this is just a little report noting the parameters that I used for that classification, and then some class change statistics so that I can see exactly what was done to the point cloud. If I need to replicate or I want to use similar settings in a future classification of this point cloud or something else, I'm able to do that by referencing this report and the parameters that are noted there. So this is just a little bit of reporting that was added to that automatic analysis that I did as a precursor to some of the manual classification we're going to look into now. So I've got the manual classification tool set out, and this is a dockable window. I can pull it out. I can dock it anywhere I want, but I like it sort of over to the side with my control center. And we've got selection modes at the top. This allows me to select any data here. We can see that on the corner of this building, I've got some, railings on the roof, or maybe that's the edge of a sign that's been misclassified as vegetation. So perhaps I want to correct that. Now, I'm just going to clear my selection and move to a polygon select. So I can select just my corner of the building and maybe this center area that I also think is some misclassified vegetation. I've selected that. We can see that in the 2D and 3D views. And before applying a different class or unclassifying these points, which is what I'll be doing, I'm going to filter the points to be classified. Now, this isn't filtering what points I'm selecting. This is not filtering what points I am showing in Global Mapper, but it's going to filter what points receive the chosen classification that I'm going to apply. So I only want to reclassify my vegetation types. I'll click OK. We still have all the points selected, but only some of them are going to receive the classification. And we can see all our familiar icons from our manual classification toolbar. And then we've got this other one for unclassified at the corner here. Clicking there, I've just unclassified all the vegetation points that were in my selection. I can come back here, opening that tool again resets these options and, clear my selection. Another cool addition to manual classification with this tool set is this option to keep classifying as points are selected. So if I enable that checkbox, what this does is make these classification options sticky. So now when I click unclassified, that button stays highlighted. And it means that as I select points in my view, that chosen classification will be applied. So it makes the process of manual classification a little more efficient here. So, I can go through and select an area, and that should unclassify some points for me. If it didn't, that's because I didn't confirm my reselection of my filter. So if I select now, after removing all the filters and confirming that selection, I've just unclassified an area of points. I believe this is a truck sticking off the side of a building. Now I've unclassified ground because I had no filters applied there. Of course, I can clear my selection, and then, as many things in Global Mapper and other programs, a really useful tool is undo. So just Control Z undoes that most recent manual classification. So this option to keep classifying as points are selected, making these classification options a little bit sticky, is really useful, and undo helps that as well in case you accidentally select some points and change the classification. It's a pretty quick process to undo. One more thing that I want to show with this manual classification toolset, disable that option for now, is that this works not only in the 2D view. Often it's helpful to look at point cloud data in a cross-sectional view. So I've got my path profile tool open, just drew a profile down the length of this truck. And what I can do here is select my points that I want to change the classification for. I can use one of my existing buttons, or we also have this drop down. This is new as well with the tool set. It allows me to choose from any Lidar class and apply that classification. So I can choose something that doesn't have an explicit button here, click the classification button, and I've just changed the class for all of my selected points. So a really useful tool, works across different views of Global Mapper, and it makes manual classification cleanup quite a bit easier when you're working with point clouds in Global Mapper.
Yeah, there's so many points I like about that, so many features I like about that new tool set there, even just from the unclassify button. Mac, we had a question come in. While you're doing this workflow, can you select points in the 3D viewer?
Yes, you can select points in the 3D viewer. We've got sweep selection, so I can select individual points, or I can click and drag a box. Now, I clicked and dragged a box in my 3D viewer, and the selection in 3D is very perspective dependent. We see we've sort of got a trapezoid because anything within my click and drag box pushed all the way back to the skybox of my point cloud display is going to be selected. So if I disable my digitizer, we can see, I've got a square, a rectangle of points, a trapezoid of points selected. It doesn't look square anymore because I've changed my perspective. So selection in 3D is absolutely possible and can be used for, with the manual classification tool set. Related to that, we have the different selection modes open in the manual classification tool set, including the segment select. So if you've done geometric segmentation or one of the max likelihood automatic point cloud classification options, and you're able to display your point cloud by segment, you can use that segment select tool to select entire segments and then apply a class manually. And that segment select can be done in the 2D view and I believe the 3D view as well. So with that, I'm going to clear my selection. And before I hand the screen back to Jeff, I've got another little tool, a little improvement that I would just like to highlight here relating to some point cloud data. So I've got my point cloud. I've got some different classes represented. Point clouds in a Lidar format like LAS or LAZ typically come along with a bunch of different variables. Or a bunch of different attributes, I'm sorry. And in version 26.1, we are now able to split the point cloud based on those attribute values. Now, this is a function that's been in Global Mapper that you have been able to apply to layers of points, lines, and polygons, or traditional vector features for quite some time, but we've extended that to point cloud data. So I can split my point cloud based on a discrete value here. Source ID, I've got return number, I've got classification as my options. So I can split by classification, and we're working with 3.4 million points, it looks like, so it's going to take just a second to run through and split out these different classes into some different layers. But just like splitting a vector layer, Global Mapper is going to create a little layer group with each of the split sections of my data nested under that, allowing me to work with them separately, export them separately, or turn them on and off from visualization here. I'll turn off all my building points that I've split out. So another great tool for a little bit of data organization or manipulation as you're working in Global Mapper with some point clouds.
We're going to move now into the idea of automatic point cloud classification. For those of you who are familiar with Global Mapper or have been using it for a while, I'm sure you've been aware of the transition we've made, that in addition to the traditional, we'll call them algorithmic based classification methods, we've slowly been adding some machine learning methods that are basically driven by geometric and semantic segmentation. Those have given us the ability, to handle some of the new modern point clouds we're seeing, whether we're talking, super high density, terrestrial, photogrammetric, et cetera. And so as we see those methods process some of that data better, we're adding them to the application. One place where it took us a really long time to beat our existing methods, if you will, was power line classification. So we didn't just go ahead and throw that into the tool. We kind of worked on it for a little bit. Great, Lidar point cloud developers and development team. And now that we've gotten the point cloud classification to a point with the maximum likelihood methods, where we find in many cases it outperforms the traditional methods, we've added that as an option to the application as well. So let's go ahead and take a look at that here. And what we're looking at is a point cloud scan, actually from one of our partners over at Lidar USA. And this point cloud, let's go ahead, we'll take a look at it in 3D quickly. It's a really high quality scan. So we're just looking at it by elevation now. But look how well we can see the tree structures, buildings under the trees. Let's see, our target today is some power lines. So from this perspective, you can just sort of see some power lines through the trees. We'll look at it this way as well, right? So we can really see clear, neat structures, but also the complexity of, power lines at different heights running through vegetation in some instances, running along, I think this data set has some vines along the road and things like that. So it gets a little messy, and we want to be able to still identify those power line features well. So the automatic point cloud classification tool now has we'll just shrink everything else here because we don't need these options, now has a maximum likelihood method for power line identification. And what this allows us to do is define just a few components of your power lines, basically the minimum maximum height above ground. You can also specify for the global setting a minimum power line length. So maybe you want to say, I only want power lines of a certain minimum length. That is helpful for, a LiDAR scan may not grasp the entirety of the power line. For example, if you see where my cursor is here, right, those lines have gaps in them given how the LiDAR falls. So we're accounting for some of that. And rather than making us wait and watch this, I did this a little earlier. And let's go ahead and take a look at the point cloud colored by classification. I'm just going to zoom in here a little bit. So of interest are the power lines, but we'll see we have our tree vegetation classified, our buildings. We even got a couple little sheds under the trees and things like that. So as good as the classifier is, this is also a really well-flown data set. And so what I want to point out here is specifically, we'll go take a look in 3D as well, is the power lines through the trees, because the tool really handles this well in the fact that it can follow the linear structure and identify those features. So let's go ahead, and I think I saved a couple views here. So, right, looking from the house out to the road, we can see how the power lines trace through the trees. And then conversely, if we look along the road here a little bit, we'll see, well, how the power lines get grabbed and identified right through the trees there. This is one of the poles that had some vines on it, so it kind of looked like trees to the classifier. Always something you go in and manually clean up if needed. But this did a really great job of identifying those power lines. And I'm thankful that Mackenzie had a report saved, because I had meant to save a report with this and forgot to. But the enable reporting option in the app, basically you turn it on, choose where you want your reports to save. And you also get a little pop-up in the app window so you can see that report running live once the application is done processing the data set. So really handy tool to have there. Let's go ahead. We'll keep talking about point clouds, but now we're going to shift gears a little bit to quality control and what goes into that in terms of point cloud analysis. So the Lidar QC tool has been in Global Mapper for a couple of years now. And over the past release or two, probably since 26, we have really started to sort of add some new functionality bit by bit, kind of ahead of some larger updates that are coming next year. But so what we have added, I guess version 26, was for users now have a variety of options to choose from when they are choosing how to fit their model. So they can do piecewise affine, a fixed shift, just Z shift, or a best plane fit where we define best fit planes around control points and allow users to apply the shift that way. Now, an important next step to that is being able to review and adjust your control points. Yes, we're using our control points, and presumably these are recorded in the field, maybe with a high accuracy GNSS, RTK-enabled device, whatever the case may be. But that doesn't mean that they're always perfect. And we want to have the ability to review them before we include and apply them as part of our QC shift to the point cloud. So we'll see, each of these control points, the large red points, they have a elevation associated with them, and that's what's going to be used in the fit process. The first launch window of this tool essentially tells us choose your point cloud, choose your GCPs. These settings control your search area. Oh, hold on, sorry, let me clear my selection. There we go. And so what I can do then is review some of the statistic information about my GCPs. And the first thing that stands out to me is the RMSE is relatively high, 7 meters. If you're trying to fit a data set, that's pretty high. And I have one point with a very high RMSE value in relation to all the others. What I can do now is disable that point. The statistics of the overall fit will live update. And I can see, maybe I don't really have any other outliers here, right? My overall RMSE doesn't change too much because those are all pretty accurate. But now I can very easily remove any points that might be outliers. So maybe, my GPS device lost signal while it was recording that point, or, who knows what happened. But now I can clearly see and exclude it and go ahead and apply my fit. Ask me if I want to be sure. In this case, I'm using the best fit plane method. I find that to be a little bit more appropriate for some larger high density data sets, especially where we have a good variety of control points. So we'll do that, and that'll just run, and it'll adjust the points in the point cloud. And generally speaking, there's not much of a visual to be had there. So I saved just a copy of the original cloud that I didn't shift. And let's go ahead and take a look at those points. I'll have to adjust this here, so give me a sec. I gotta drag it on screen, but as we take a look at the profile here, this is I think a trailer, like a construction site trailer, you'll see the black and white or grayscale colored points are the original ones, and then the colored points with the RGB value are the ones that have been shifted. So this was not a massive shift as we saw, fractions of a meter, but another way to confirm that happened just with an easy visual there. So if you're someone who does a lot of point cloud QC work and GCP-based adjustments, definitely go ahead and take a look at these related updates, and more to come with our next release as well. Okay, Mac, do you want to talk to us a little bit now about pixel to points?
I sure can. So I am going to share my screen once again, and we will talk a little bit about an update to the Pixels to Points tool. Now, for folks who may not be familiar with this tool in Global Mapper Pro, it is a tool that takes drone or UAV collected images, so geotagged images, and processes them into some different outputs. So the primary output there is going to be points, a point cloud, hence the name Pixels to Points. And we are also able to create a textured 3D mesh feature, as well as a rectified ortho image. So a lot of great outputs that you can create from just geotagged images that were captured with a drone. The improvement to the pixels to points tool that we're seeing that we have included in version 26.1 is having to do with the color harmonization options. So this is the pixels to points tool full dialog. I've got some images loaded in here. The image listed in red, I've chosen to set as my reference image for color harmonization. And the option to enable color harmonization is over here on the side. When I click that checkbox, this little pop-up is the new dialog in Pixels to Points, and it allows me to choose the method that will be used for this color harmonization. We've got 3 methods: full frame, matched points, or the LD segment. Full frame is going to take into account all of the points found within an image. Matched point is going to take a subset of those around each point to try and color balance the images. And then VLD segment is more suited for flights at maybe an oblique angle where you're trying to reconstruct the vertical walls of, say, a building or some vertical faces in the pixels to points tool here. So I, by no means, am an expert at these different color harmonization methods that are available, and we do have them documented if you want a little explanation about each of them. But I've processed a couple of them here in this workspace, and we can just take a little look at what this might do. So color harmonization, generally used if you've got shadow on part of your flight, say the sun was going down or behind some trees as you were flying, or with certain camera settings, harmonizing or balancing the color in the data set could be useful. So as I turn on this second generated ortho image, there is just a slight shift in the colors for this small sample of collected images of a golf course. And we can see that the matched points method creates a slightly darker image with some different undertones because it's using, points closer to local neighborhoods when it's doing that color harmonization, as opposed to the full frame method. The brighter image here is taking into account all of the points within each frame. So just some different options there to help maybe improve the visuals that you're getting from the Pixels to Points tool. And of course, I'm showing the ortho image outputs here, but those changes to the colors in the data also carry over to the RGB colors in our point cloud. So that 3D output that you get from Pixels to Points.
Awesome,
I
thanks, Mac.
see we might have a question here. The question is this just for drone or UAV collected images, or does it work with aerial images as well? And that's in reference to the general Pixels to Points tool, and it is for those single point geotagged images, not fully rectified aerial imagery. The Pixels to Points tool works with the structure from motion process, where we're taking the camera location when the image was captured and doing some math to find the overlapping areas and recurring pixel patterns in the different images in order to construct the scene in 3D. So it is just geotagged images, which you typically get from a drone or UAV. All right, so I think that handing the screen back to you, Jeff, to continue down our list of new features.
Yeah, that sounds good. Let's go ahead. We'll switch gears a little bit and move away from point clouds and start to look at some new features in the Global Mapper Insight and Learning Engine. And so I mentioned earlier, Insight and Learning Engine was released at version 26, and it's currently houses all our deep learning powered image analysis tools. Anybody with a pro license, a Global Mapper Pro license that is, has access to this if you're running the latest version, which now is version 26.1, but you'll have access to that for free through probably the 26.1 release cycle. So new in this release are a couple different things. We have been working towards making this a more feature and functionality complete tool set as it starts to slowly mature as a tool. And what we have added now is a variety of ways to sort of manage and work with your models. And then also some new methods for sharing, updating, and otherwise kind of perhaps working between different machines or colleagues or whatever the case may be. So let's go ahead and take a look at that in the app. So first, what I have here is just some imagery from, happens to be from Toronto, Canada. And what we're going to address in this scenario is that in the situation where my imagery that I'm working with might differ a little from the imagery that the model was trained on, I might want to work through a process called fine-tuning or retraining. And the new feature here is that now the vehicle detection models can be retrained as well. Initially, they did not have that functionality, but they do now with version 26.1. And so what that means is, let's take a look at object detection and specifically vehicle detection. But each method or each detection option will tell you, give you a little bit of range of where we expect these types of models to work well. And so if perhaps you load data that's different from that, or your source data is a little different, you may want to fine tune or retrain that model. What I can do with that process, or what that process entails, is taking some type of ground truth. In this case, for vehicles, it's bounding boxes around the vehicles, and using that to update the existing model. And so the way that process works is, or can be done two different ways. So let's say I'm just going to name my model test for today and make sure that I'm training the vehicle model. What you do is you have control over a couple parameters that control basically the iterations, control how many times the training data is reviewed in the model, and the batch size is effectively how much data is viewed at one time. Traditionally, this one is set to an estimate of what your machine memory can handle, so you don't often have to adjust that one, but you can toggle it as needed. Vehicle detection happens to perform a full retraining at this stage. It will fully retrain your model. And in this case, I used some existing ground truth data that was paired with this data set. If you don't have it, you can in fact go ahead and make your own writing global mapper, outline your vehicles, and use that as the basis of the training. I don't need to do that right now, but that is an option. I know not all of us have existing ground truth data for everywhere. Other than that, you go ahead and click Start Training, and the only other step before this process runs automatically is to make sure you pair your control layer, your ground truth layers with your raster layers. And in this case, I only have two data sets, but you can drag and reorder them as needed. You go ahead, hit OK, and the process will run. That takes a little bit, so we're not going to do it now, but we'll see. Let's go ahead and look. What a result might look like then is in the Custom Models tab, I then have access to any custom models that I have worked with in the past. I can choose that and then run the inference to identify, well, in this case, this would be a building extraction model. But again, you could use that for any of your trainings. So going along the lines of kind of custom models and custom training, we've also added a dedicated configuration section for some sort of advanced work with the Insight and Learning Engine. So all of the built-in models that we provide are available and showed in a list. And you'll see they have a status here called up to date. if we ever release or update a new model, that may not necessarily align with the release of the app. You can go in here and check for any models that need to be updated. You can download your selected or download all the updates as needed. It's a really handy way to kind of keep up to date with um, the work we are doing and as we provide those models. This custom model section then will list anything that you have custom trained, whether you did that on your machine or perhaps a colleague shared it with you. So you could export a selected model. You could delete it. Maybe you had a bad test and you don't want to use it anymore. You can delete it, or you can import models from your machine. And in this case, so maybe I want to bring in this land cover model. It will now show up as my custom model, and it'll be available when I go into the tool, in this case, the land cover tool, custom model section. I can now see and use that test here. The benefit of this sort of functionality is that oftentimes a fine tuning or a full retraining can take time and be computationally intensive. That's just kind of the nature of the process. And so what we're seeing is that our users might be running this heavier work all on one machine. So it's either a machine where you run all your fine tuning and you're retraining because it's high spec hardware. Well, then when that's done, you just export it. It exports as a zip, and you send it to whatever end user colleague needs to work with it as an inference to then detect those images, those features or objects in other data sets. Let's see. It looks like we've had a lot of questions come in here. Let me go ahead and take a look.
One question that jumped out at me, Jeff,
Yeah.
that I think that you could speak to is
Mhm.
just going over what built-in models the Insight and Learning Engine offers for this image classification. Um, Someone was asking whether Global Mapper can, train completely different, train your own
Mhm.
objects, or must you base something on a pre-trained model that is shipped with the Insight and Learning Engine?
Yeah, that's a great question. Thank you to whoever asked that because I skipped over that a little bit. So the Insight and Learning Engine currently has three types of things it can detect automatically. Land cover classification. So that's creating a land cover classification map um, of your data set. Uh, Traditionally, some of the public models, at least, here in the States, right, those are maybe 5-10 meter models. Where we wanted to focus was on higher res data. And so, meter, sub-meter data, where you may have acquired special imagery, maybe you're doing it orthomosaics from a drone flight, whatever the case may be, but you still need to calculate land cover classification. And so that's what that tool does. We then have object detection. Object detection at this point currently covers buildings and vehicles. And what that allows you to do is either identify building features or vehicles in your imagery. Each of these, again, is trained on a relatively high res imagery, right? We're looking for pretty small objects, all things considered. So from about 3 to 30 centimeters for buildings, or about 2 to 20 centimeters for vehicle detection. As to the question of, can I train this on anything or something else? So one of the questions somebody had was a user had previously asked about, they were counting like dry dock ships in a shipyard. So maybe not all that different from a vehicle, but certainly not detected by the vehicle detection process. And you could certainly go ahead and attempt to run a full training, assuming you have the ground truth. Like in that specific case, where the test was maybe trying to do it on vehicles, and fully retraining that model to identify those unique features. Now, of course, caveat being, depending on how different the feature is from the source model, your results may vary. That being said, one of the things we are heavily working on in our R&D team is the ability to provide, in fact, a general model that will allow you, the user, to determine what it is you would like to identify. That is still very in the early stages and very much a lofty goal, but it's something we're working on and are hoping to figure out, right? Because we acknowledge that we can't build a model for every type of object. Somebody I just saw mention pools or airplanes or whatever the endless cases may be. But if you have the data, we can give you the model to do that, and that's our hope. Very much a product in the early stages of R&D, but hopefully something that we would like to be able to do. Any other quick questions I could grab now, Mac, before we think about wrapping up?
Someone asked if you had an example of land cover classification and maybe the results from that. I'm not sure if you have that on hand, but if you go to our YouTube channel, where this webinar will eventually be posted, we do have various other videos and content that go over some of the different tools in the Insight and Learning Engine, and detail some of the land cover classifications, showing that process and some results from that process as well.
Yeah, that'd probably be the best way to do it. I've never tested this data set on land cover. It wasn't really designed for that. But the tool itself is very quick. You are effectively only choosing what input layers you're working with because the tool should auto detect the type of imagery you've loaded. Generally speaking, we've trained the model on data ranging from 0.5 to 1 meter. So anything in that range would be where you want to start. And then it's just a matter of start inference and go ahead and let that model run. Alrighty. So for those of you who have even more questions about the Insight and Learning Engine, as I mentioned earlier, it should be available through August, September 2025, as long as you have a Global Mapper Pro license. You'll be able to download all the models and necessary tools as part of the installer. If not, you can do it in configuration. I showed those options there as well. As always, when we have a new tool, we're looking for feedback. So please go ahead, take a look at it. Tell us your thoughts, what you may want to see in addition to what's there now and things like that. What you need helps us grow our tools. So that's always a really big help to us. Let's see, Max, should we take a look? Do we have any other questions that have come in that we could get to quickly here?
We're getting some good questions, although some of them are a little more specific and in depth. So I'm not sure we've got any general questions on our new features here that we could answer quickly. I just want to reiterate that, if you're interested in these features, we do have additional content coming out on our YouTube channel showing some of them. And then you can, of course, upgrade to Global Mapper Pro 26.1 if you have that upgrade option available to you. And if you're not a Global Mapper user, I, of course, encourage you to download and test out a free trial of Global Mapper Pro to sort of get a sense of what the program can do with your data. As Jeff just mentioned, we do a lot of user-driven development. So you guys are the experts at what you do and the data that you work with. So there is really nothing more valuable to us as product managers than the feedback we get from users and what they would like the tools to do, and what we could be doing better.
Yeah, absolutely. So again, just one last thought. Short version being, if you're in the process of trying to upgrade, take a look at our website or email our sales team, authorized at bluemarblegeo.com, and they'll be able to get you all the details you need. Alrighty, so thank you for joining us today. And Mac, thanks for your help as always. Please reach out to us if you have any other questions.